Whole numbers. In this chapter, we will understand the following concepts: predecessor and successor, number line, addition on the number line, subtraction on the number line, multiplication on the number line, and properties of whole numbers. The whole numbers are the complete set of positive numbers from 0 to infinity. All the numbers like 0, 16, 24, 46, 895, 1600 or 20,000 are all whole numbers. Whole numbers do not include negative numbers, fractions or decimals. Before moving on, let's understand the concept of predecessor and successor. We all have played that game, what comes after and what comes before. Playing this game with number 7 will have the solution that it is 6 that comes before and 8 that comes after. The terms predecessor and successor refer to the same concept. Here, 6 is the predecessor of 7 and 8 is the successor of 7. So, predecessor is what comes before and successor is what comes after. It is easier to find predecessors and successors of small numbers, but how do we tackle the bigger numbers for this? Just remember a simple formula of +1 and -1. If you subtract 1 from the number, you will get the predecessor. And if you add 1 to the number, you will get the successor. Now, can you tell what is the predecessor and successor of 2485? You got it right if you think 2484 is the predecessor and 2486 is the successor. So, go back one step to get the predecessor and go forward one step to get the successor. Now let's talk about number line. A number line is a straight line with numbers placed at equal intervals or segments along its length. The distance between any two given points, for example 0 and 1, is called unit distance. A number line is usually represented horizontally and can be extended infinitely in any direction. With the help of a number line, we can also do addition, subtraction, and multiplication. Let's see how we can use number line for addition. Let's take a simple example like 1 plus 3. Now, how do we find an answer to 1 plus 3 with the help of number line? We start with 1 and move 3 spaces from there. We land at the number 4. So, the sum of 1 plus 3 is 4. Let's take another number, say 5 plus 4. As we had done earlier, we will start with the number 5 on the number line and move 4 spaces from there. This way we will land at number 9. So the sum of 5 plus 4 is 9. Now let's see how we use number line for subtraction. Let's take a simple example like 5 minus 2. We begin from the number 5 on the number line. Now remember that we have to subtract, so we will move backwards on the number line. So from 5, if we move 2 spaces backwards, we reach 3. So we get the result of 5 minus 2 as 3. Number line can also be used for multiplication. Let's see how. Let's try solving 5 into 2. We know that multiplication of 5 into 2 means having 5 groups of 2. This is a group of 2 on the number line. Now we have to jump such groups of 2 5 times. Jumping groups of 2's 5 times takes us to 10. So 5 into 2 turns out to be 10. In this way, we can use number line to carry out multiplications as well. Now it's time to understand the properties of whole numbers. The first property is closure property. If you add or multiply two whole numbers, then its result is also a whole number. That is, whole number plus whole number is equal to whole number. And whole number multiplied by whole number is also a whole number. For example, if we add two whole numbers 5 and 6, the result is 11, which is also a whole number. If we multiply two whole numbers 4 and 8, the result is 32, which is also a whole number. Let's see how the closure property is not applicable on subtraction and division. If we subtract a whole number 3 from another whole number 8, that is 8 minus 3, the result is 5, which is a whole number. But if we subtract 8 from 3, that is 3 minus 8, the result is minus 5, which is not a whole number. Similarly, if we divide whole number 8 by another whole number 2, the result is 4, which is a whole number. But if we divide 9 by 2, the result is 4.5, which is not a whole number. So we have seen that closure property works in addition and multiplication as we get whole numbers as a result. But in case of subtraction and division, we may or may not get whole number as a result. So the closure property is not applicable on subtraction and division. The next property is commutative property. Commutative property of the whole numbers tells us that the order of addition does not change the value of the sum. If a and b are two whole numbers, then a plus b is equal to b plus a. That is, 10 plus 2 will be equal to 2 plus 10. 10 plus 2 is 12 and 2 plus 10 is also 12. The order of multiplication also does not change the value of the sum. A into b is equal to b into a. That is, 5 into 2 will be equal to 2 into 5. 5 multiplied by 2 is 10 and 2 multiplied by 5 is also equal to 10. So, as per commutative property, we can add or multiply in any order. The result will be the same. This property is not applicable on subtraction. If we change the order in case of subtraction, then a minus b is not equal to b minus a. Let's see how. If a is 5 and b is 2, then 5 minus 2 is not equal to 2 minus 5, as 5 minus 2 is 3, while 2 minus 5 is minus 3. Commutative property is not applicable in case of division also. If we change the order in case of division, then a divided by b is not equal to b divided by a. If a is 15 and b is 3, then 15 by 3 is not equal to 3 by 15, as 15 divided by 3 is 5 and 3 divided by 15 is 1 by 5 or 0.2. Now let's move on to the next property, which is associative property. This property is associated with addition and multiplication. In case of addition, if we have three numbers to add, then we can add any two numbers first and add the third number to the sum of the numbers added earlier. We will get the same answer. Let's take an example. If we are adding three numbers a plus b plus c and choose to add a plus b together and then add c to it. On the other hand, we choose to club B and C together and add A to it. The sum would remain the same. Let's say for A, B and C, we have numbers 2, 3 and 4. Let's see what happens when the sum of A and B is added to C, and on the other hand, the sum of B and C is added to A. The addition of A and B, that is 2 plus 3, gives us 5. Now we add 4 to the sum of A and B and get the answer 9. On the other hand, we first add B and C, that is 3 plus 4. It gives us 7, and then add 2 to it. It makes it 9, which is same as in the first case. It means you can pair the numbers in whichever way you want. Now let's see how associative property works in case of multiplication. When we multiply 3 or more whole numbers, the value of the product remains the same when they are grouped in any manner. If A, B and C are 3 whole numbers, then the product of A into B multiplied by C will be equal to A multiplied by the product of B and C. Here also, let's take A, B and C as 2, 3 and 4. In first case, we multiply A and B to get 6. Now we multiply it with C, that is 4. 6 into 4 is 24. Now let's see how it goes on the other side. Multiplying B and C, that is 3 and 4, we get 12. Now multiplying A with 12, we get 24, which is the same as the earlier case. Please note that associative property is not applicable on subtraction and division. Now let's talk about the last property, which is distributivity of multiplication over addition. Now what does multiplication over addition mean? It means if we have 3 numbers such as A is multiplied by B plus C, according to the distributive property, we will first multiply A with B and then we will multiply A with C. So the equation becomes AB plus AC. Let's take an example to understand it better. Let's take A as 4, B as 3 and C as 2. So now what we have is 4 into 3 plus 2. 4 into 3 is 12 plus 4 into 2 is 8. So the answer that we get is 12 plus 8, which is 20. But why didn't we solve 4 into 3 plus 2 as 4 into 5? Wouldn't that have been simpler or easier? In case of simple calculation like this one, yes. But in case of calculations with bigger numbers, using distributive property helps you simplify your calculations. Let's take up a bigger calculation to understand this. If we have to multiply 250 with 102, the calculation will be pretty long. What if we use the distributive property and represent the numbers as 250 into 100 plus 2? 250 into 100 is very simple. Just add 2 zeros after 250. It becomes 25000. Now 250 into 2 is also very simple. It is 500. Now all we have to do is add 25,000 and 500 and we get our answer as 25,500. There was no need to go for a long drawn multiplication.